Renaud mentioned, I'm going to cover in this presentation the integration of the role of nature-based solutions in indicator-based risk assessment. And I will focus quite generically in terms of reducing disaster risks. So not specific risks such as risks to livelihood or to other components of our lives, but disaster risk more generically. My presentation will have an introduction on which I'll frame the risk assessment, but also the nature-based solution context. And then I will go into the core of the presentation at looking how we can integrate the indicators that are relevant for the use of nature-based solutions for risk reduction. I will then go a bit further with linking this work to other intergovernmental processes. That's, for example, the Sendai Framework for Disaster Risk Reduction or the Sustainable Development Goals. I'll then cover the importance of having participatory approaches when we want to go into these directions. And also at the end, I'll finish by talking generically about the advantages and limitations of indicator-based assessments, but also in the specific context of using indicators for nature-based solution. So my presentation is really focusing solely on indicator-based types of risk assessments. There are many other ways to characterize risks, so just keep this in mind. So everything that I'm going to be talking about is englobed into the generic risk assessment framework that was presented by the IPCC back in 2014, where you can see on this figure that risk is composed of hazards, vulnerability, and exposure. Now, this formulation is or conceptualization is valid for any types of hazards, not just climate-related hazards, as you can have with the IPCC framework, but all hazards that affect humans and ecological systems, or as I will refer to it at length, socio-ecological systems. There is a new formulation that has been published in the latest IPCC reports back in 2022, where you can see on this figure the addition of a component that's called response. And here it's really to try to see how responses to the impacts of hazards is then influencing in backward loops the hazard, the vulnerability, or the exposure components. However, in the work that I'm going to present, I use more the concepts that is on the left-hand side, so the first risk assessment framework that you can see there. Now, as Renaud mentioned, I work a lot in coastal areas and in deltas in particular, so a lot of the examples I'm going to use are from these kinds of landscapes. And of course, these landscapes and coastal area in general are affected by a multitude of hazards. And you can see here hurricanes and of course storm surges, but there are many others such as coastal flooding, such as coastal erosion, and many other types of hazards that can be affecting the social ecological systems. And deltas in general, river deltas in general, are at the forefront of the impacts of these hazards. In a seminal paper, J.I. Savitsky and co-workers back in 2009, classified major river deltas and how in peril they were with respects to flooding. And in the list of deltas that they had some 38 deltas that they categorized. They looked at deltas in Asia, in Africa, and all across the world, and had these classifications such as deltas in peril or deltas in greater peril. And you can see two examples here of the Irrawaddy Delta in Myanmar, where information at that time showed that the 20th century aggradation rate was 1.5 millimeter per year, yet the relative sea level rise was 3.4 to 6 millimeters per year. So you can see here the difference between the aggradation and the relative sea level rise, meaning that the probability of flooding of this delta is huge, and thus the categorization under deltas in peril. Even worse, perhaps, was the example of the Yangtze River here, where the degradation rate was 0 millimeter per year, with a relative sea level rise of 3 to 28 millimeters per year. So this just to highlight the fragility of these landscapes that are extremely important because you have huge concentrations of population in most of the river deltas. You have concentration of wealth, particularly in terms of urban areas and megacities, and also a concentration of agricultural activities, which play a very important role for the economies of the countries where these deltas are located. In a review that was led by Dr. Émilie Crémin, and in the frame of the Living Deltas Hub project, to which Rihua and myself and many others contributed to, we did a review of what we call tipping points in river deltas. So try to characterize these extreme changes that can happen in a river delta. And one of the most extreme cases when a delta disappears completely, and unfortunately, this does happen. In this review, we tried to look at the causes of tipping points, the characterization of these tipping points, and the consequences of these tipping points, knowing that tipping points can be both positive or negative, so it can have positive outcomes for society, but in most cases, negative outcomes. Now, I don't want to go in detail into this figure because it's a complex figure, but what I wanted to highlight here is the fact that when we're looking at these tipping points, when we're looking at the consequences of natural hazards that I showed before, we have to understand the system completely. We have to understand the geophysical, the ecological, and the anthropogenic drivers that lead us to these tipping points or that lead us to disasters. Just to give you a simple illustration of how a tipping point can look like, and perhaps in a non-catastrophic manner, you could have climate change and the combination between climate change, therefore sea level rise, and land subsidence that leads, when combined, to relative sea level rise, that increase salinity intrusion into a coastal area or a delta. The tipping point here can be a shift from freshwater agriculture to a brackish aquaculture. And this shift has many consequences on the ecology. You have a freshwater system, and then you're transferred to a brackish water system. But in terms of social and economic differences also, there are huge shifts. The consequences can be positive, for example, in terms of increasing economic growth. But here again, you can ask the question, who benefits from this economic growth? And can often, in this specific example, be negative with environmental degradation that is induced both by the salinization process, but also by the development of a practice when it's done intensively that pollutes the environment considerably. So this is just to give you an example of some of the changes that can happen in these landscapes. Now, to protect ourselves in coastal areas and in deltas, more specifically against the natural hazards or some of the tipping points that we looked at, we traditionally go for engineering structures such as a sea dike, as you can see here in the Mekong Delta. Increasingly, though, we're looking at what are called nature-based solutions. So how we can work with nature, how we can benefit from the ecosystems that are in place, or when we restore these ecosystems to actually protect us against hazards, against tipping points, and how this can also bring additional benefits, which I'll talk about a bit later on. In many cases, also, you have a combination of both. So you'd have a combination of the engineering solution and of the nature-based solution, which are then called hybrid solution. And in many cases, you have the best of both worlds when you have these types of approaches. And actually, in the picture that I'm showing here, the mangrove forest that is just in front of a sea dike actually protects the sea dike, so reduces the costs of maintenance of the sea dikes, in addition to contributing to an attenuation of wave effect on the landscape. So I've talked about nature-based solution. Let me just show you how this is taken up on the policy scene. And nature-based solutions have been defined originally by the International Union for Conservation of Nature, or IUCN, but also by the European Union. And the most recent definition that we have, which is on a political consensus, is from the United Nations. And I'm not going to read the text that's here, but what is important to keep in mind is that nature-based solution consists of actions such as protection, conservation, restoration, etc., that benefit human well-being, but also benefit the ecosystems. So you really want to address societal challenges, and you want to achieve human well-being. You want to achieve biodiversity benefits simultaneously. And there is a whole suite of practices that that fall under the umbrella of nature-based solution. And this is actually a categorization that was done by the IUCN back in 2016, ranging from efforts on ecosystem restoration to ecosystem protection approaches. In this presentation, I'm focusing principally on what is called issue-specific ecosystem-related approaches, and this is ecosystem-based adaptation and ecosystem-based disaster risk reduction. There is also increased scientific evidence that nature-based solutions play a significant role in reducing disaster risks around the world. This is based on a survey that was published in 2021, led by Dr. Karen Sunmeyer-Reer. And we looked in this review at papers published for specific types of ecosystems, such as urban ecosystems, coastal ecosystems, mountain ecosystems, etc., and also a few key or cross-cutting topics, such as the economics of nature-based solution and using ecosystem-based approaches in disaster risk reduction. The part of the figure on the left is the one I'd like to concentrate on, and this is basically trying to evaluate the confidence that we have that nature-based solutions actually are able to reduce risks from these natural hazards. And this is done by looking at the level of evidence that was provided in the papers that we reviewed. So, is there empirical evidence that there is a reduction in terms of the risks by the deployment of nature-based solution, and this by affecting either, the hazard characteristics themselves, the exposure of the systems, or the vulnerability of the systems. And what is the level of agreement? And that's the level of agreement that we had as reviewers, that's the statement ecosystems functions and/or ecosystem services attenuated the hazards and allowed to reduce the risks. So by combining these level of evidence and these level of agreements, we can determine the level of confidence that we have in terms of the effectiveness of these nature-based solutions. And from the figure here, you can see that for a lot of the systems that we looked at, particularly the mountain, the urban, the forest and vegetation systems, we have high confidence that they play a significant role. There is perhaps more evidence that is required with medium confidence in terms of dryland systems or rivers and wetlands systems that needs still to be reinforced by more empirical research. But this figure clearly shows that there is more and more scientific evidence as to the effects of the positive effects of nature-based solutions in reducing risks globally and in many different types of configurations. The additional benefits that we have with nature-based solution is that not only do they provide what are called the regulating services, such as in the example that I will go through the next 3 slides here of a mangrove system that can regulate erosion, that can regulate certain types of environmental hazards. You can think about coastal erosion, you can think about coastal storm surges, for example. But they will also store a lot of carbon, so they play a role in terms of climate change mitigation. And also by being present on the coastlines, they reduce the exposure of both human beings and human assets by creating more distance between the hazards, so to say the wave action, and where these people live and where the infrastructures are located. In addition to that, though, they will also provide what are called provisioning services. So you can extract food from mangrove systems, you can extract firewood from mangrove systems, you can develop livelihoods around mangrove systems, such as beehives and honey production. Of course, all that has to be done sustainably by not damaging the systems, the mangrove systems themselves, but these livelihood options are possible. And the last one, but not least, are the cultural services, such as the creation of opportunities for recreation and tourism, and also the importance of cultural heritage for the populations where these ecosystems are located. Now, all these dimensions actually contribute to the different components of the risk assessment, whether it's in terms of the hazards when you're thinking about the regulating services, in terms of the exposure, but also in terms of the vulnerabilities, in terms of the provisioning and cultural services. I come back to the review that we did on the tipping points in deltas, if you remember, and also what we extracted from this review are actions that would prevent reaching negative tipping points and enhancing the possibility of positive tipping points in these delta environments. And what I've highlighted here with the red boxes are components that were, again, this was from the papers because it was a review, the dimensions that are linked to nature-based solution and prominently is to restore coastal ecosystems and implement green infrastructure. This is the most direct link you have with nature-based solutions, but also, integrated approaches for river and coastal zone management, development of climate smart agriculture, etc., all have links with nature-based solutions and their principles. So in these review papers, the role of ecosystems in terms of preventing the negative tipping points and enhancing the positive tipping points was also recognized already. Now let me talk to the core of the presentation, which is how do we integrate more prominently the role of these ecosystems in risk assessment frameworks. Now, there are many, many different types of risk assessment frameworks. I'm just going to show you one as an example to make the argument for the inclusion of ecosystem-based indicators in these risk assessments. So here you have the World Risk Index, which is published annually in the World Risk Report, which is a global assessment of all the countries of the risks to different hazards that nations face. So from sea level rise, floods, cyclones, earthquakes, and drought. You can see that the framework considers the exposure and the vulnerability. And in the vulnerability component, you will have three dimensions that we usually find, such as the susceptibility, which is the likelihood of suffering harm, the coping capacities, which are the capacities to reduce negative consequences, and the adaptive capacities, which are the longer-term capacities to change a system and to adapt to the new circumstances that you're facing. And what is interesting when you look at how the World Risk Index is computed, and particularly if you focus on the vulnerability part of it, which are the last three columns to the right under susceptibility, coping, and adaptation, what you will realize is that the number of indicators that refer back to ecosystems is very reduced, and it's only under the adaptation component where you see the environmental status and ecosystem protection that these indicators characterizing the state of the environment or the health of ecosystems appears. All the rest, and that's normal because of course the impacts of hazards are felt by societies and economy more prominently. The rest of the indicators cover these social and economic dimensions more broadly. And this is actually something that has been noticed across many different risk assessment frameworks and the indicators that are derived from these. It's not specific to the framework that I just showed you. Back in 2016, we did a review of the risk assessment frameworks and the indicators used for disaster risk reduction in deltas, again, so that was under a Belmont-funded project that was called Deltas. And we reviewed some 55 papers that were relevant, and we realized that the indicators that were used by various researchers were predominantly covering the social components of vulnerability, such as the coping and adaptive capacities and the social susceptibility. And a smaller fraction of these indicators covered the ecosystem component, such as the ecosystem robustness and the ecosystem susceptibility. And this is the column on the right, but the column on the left, where you see perhaps more prominence of some of the ecosystem-related indicators, was from 8 papers that focus specifically on social ecological systems. So you would have expected to have more indicators on the ecological component in these papers. But even in these ones, there was about 33% of indicators that were on ecosystems. Then Michael Hagenlocher and other colleagues in 2019 published a review also on drought and the indicators that are used to characterize risks related to drought. And you can see here that, again, a minority of indicators covered the environmental dimension, 9 out of 62 indicators that were in these reviewed papers. If you can add also perhaps 8 additional indicators that were linked to the farming practice dimensions, but they're not strictly purely environmental indicators. Last but not least, Aminur Shah and colleagues in 2020, we published a paper that was a review of the risk assessments that were carried out with nature-based solution in mind. This was in the frame of a project funded by the European Commission, Operandum project, that was focusing on the deployment of nature-based solution for hydrometeorological risk hydrometeorological hazards. And basically, even in papers that were looking specifically at nature-based solution, you had only 39% of the reviewed indicators that covered the ecological system. So with this in mind, it's important to understand that the role of ecosystems actually has been recognized for a long time in terms of their ability for risk reduction, and in particular in vulnerability frameworks. So this is not a risk framework. This is a vulnerability framework that is called the SOST model that was developed by Turner et al. Back in 2003. And you can see here at the center of the figure the exposure, the sensitivity, and the resilience. And you can see that in many of the components, you consider both the human and the environmental conditions, also in the exposure and also in some of the components of the resilience, not only in the sensitivity. So this interaction between human and environmental systems has been recognized for a long time in terms of characterizing the vulnerability and ultimately the risks of systems that are affected by natural hazards. Yet, as I've shown you in the previous slides, the environmental component is generally not represented to the same extent as the social and economic components. And with this in mind, in the project that I mentioned before, the Belmont Forum funded project called Deltas, we developed the Global Delta Risk Index, the GDRI, with the intention to increase the relevance of ecosystems in terms of the risk assessments. So you can see that the framework contains the hazard component and the exposure component linked, and the vulnerability component, which is in the center of the figure. And here we explicitly looked at the social exposure and the ecosystem exposure on the exposure side of the equation. And in terms of the vulnerability, we added equivalent dimensions of ecosystems that we had for the social components. So for the social components, we had traditionally, again, the social susceptibility and the coping and adaptive capacities, which I've covered before. But we wanted also to understand what were the equivalents for the ecosystem. So the ecosystem susceptibility and the ecosystem robustness. So these dimensions were added to the framework. And in terms of the computations that we were then going to carry out, you can see here at the base of the figure the exposed populations and the exposed ecosystems. And in terms of the susceptibilities and the lack of capacities and adaptation capacities, the equivalents both for the social and ecosystems dimensions. So basically, we had indicators that were relevant for all these dimensions, And I have to mention that this was for a multi-hazard risk assessment. So you can see cyclones, droughts, flooding, salinity, storm surges, and pollution. So combining all this, we did computed the risks for 3 deltas where the project was active, which was the Amazon, the Ganges-Brahmaputra-Meghna Delta, and the Mekong Delta in Vietnam. And the top figure compares the risks, the multi-hazard risks for social ecological systems compared across the countries. So you can see immediately that the risks were generally higher for the Ganges-Brahmaputra-Meghna Delta, and in particular provinces of this region. And in the lower frame or the middle frame, the risks were computed per delta. So we weren't making a comparison across the deltas, but we were making comparisons within the deltas, which perhaps if you are trying to provide solutions at delta level, this is a bit more relevant as a decision maker, where you can highlight the areas, the coastal areas, or the provinces where the risks are the highest for putting in place interventions. Perhaps even more interesting is when you start looking at the risk profile. So because you have this index-based approach, you can look at the contribution of each index to characterize the risks. And this is kind of the very multicolor column that you can see on the right of each of the sub-panels B and C that tells you to which extent an indicator contributes to the overall risk. And therefore, this is where I want to tie in with the importance of having indicators that characterize the ecosystems, because, well, if you don't have them, you cannot understand to which extent these indicators play or do not play an important role in reducing risks. So not including them means that you lose a lot of information. And that's why it's important to add them, because then you can see very concretely whether they do play a role or not. And if they do play a role, what you put in place in terms of intervention to reduce the risk. And that can be anything from nature-based solutions to more targeted approaches. I'll accelerate a little bit here, but the next evolution was not just to understand how, or adding indicators, if you will, to the frameworks, but to understand how nature-based solution really affected the dimensions of risk. So whether it's the reduction in magnitude and of the hazards, for example, of floods, reducing the exposure of the systems to these hazards, or reducing specific components of vulnerability. And here, this is not a coastal example. This is from the Panaro River in Italy. And here we wanted to look at the risk of flooding in 22 municipalities that were along the Panaro River, which is in Emilia-Romagna in Italy. And the Panaro is a tributary of the Po River, which of course then ends up forming a delta. The Panaro River is actually to the south of the figures that you can see here. The nature-based solution intervention that was put in place was to plant deep-rooted plants, on the embankments of the river to reduce erosion of these and to reduce severe erosion when there is overtopping, meaning that you protect the embankment and the embankment doesn't collapse. So that was a nature-based solution that was very localized on the embankments. And basically what we did here is compute the hazard scores for without nature-based solution, which is the top panel, and with nature-based solutions in the bottom panel. We did the same for the exposure, and we did the same for the overall risk. We didn't do it for vulnerability because the NBS itself was very limited in extent, because it was on an embankment and it doesn't affect the municipalities itself in terms of some of the other services. So the vulnerability was the same for the computations of with and without nature-based solution. And what you can see basically here is that the inclusion of nature-based solution, and through the modeling of the hazard characteristics, particularly the depth of inundation that would happen if there was overtopping of the embankment, the exposure, the overall risks are considerably reduced. And you can see this in the bottom right corner here. More visibly, perhaps, you can see it in this figure where you have the categories of risks, so ranging from low risk to high risk, and you have the area in square kilometers on the y-axis. And you can see that when you have an NBS, so that's the orange bars, the concentration of risk categories is at the low to medium range. But when you have no NBS, the spread is much more across all the categories. And actually, you have quite a lot of area that is under high risk, whereas with NBS, you do not have any areas left under the high risk. The last component for this segment is to say that we can go perhaps a bit further, and is to look at ecosystem services and try to introduce these ecosystem services into the risk assessment frameworks that I have shown before. And this is the research of one of my former PhD students, Dr. Yuting Peng, that looked at frameworks such as the Global Disaster Risk Index, which I showed you before, where you have the hazard, you have the exposure, and you have the social ecological vulnerability. But in addition to the ecosystem vulnerability and in addition to the social vulnerability, that you've seen before, you now have these ecosystem services. And why is it important to have these ecosystem services? Because they tie in the ecosystem vulnerability context and the social vulnerability context. And therefore, you're really starting to talk much more tightly about social ecological systems when you use this concept of ecosystem services here. So you can see that you have, for example, habitat degradation in terms of soil quality. This can affect your cropping systems, your forests, etc. These affect what we're calling the provisioning services, and these affect the social benefits that we can get from these services, and in turn, this can affect the social susceptibility of the system. This is just to give you a quick example of that. And Yuting applied this new framework with the new indicators on ecosystem services to the Yellow River and the Pearl River deltas in China, and generated these maps where you can see where then the higher risks are located here. And I'll go quickly over that, because I think that perhaps the most interesting part of this is that once you have this information, as I said before, you can start proposing solutions. And again, so we are in nature-based solution talk here, and what the recommendations were about ecosystem-based adaptation in this context. So you can see here for key sectors such as agriculture, you want to have the services of agricultural production and soil quality regulation enhanced, and the possible EBA strategy or ecosystem-based approach strategy that you can put in place is agricultural diversification or agroforestry or climate-smart agriculture. The benefits that you will get here are food security, income benefits, and risk reduction, which is primarily what we were looking at in terms of erosion or flood hazards. And that basically allows you to target the hazard and vulnerability component of the risk assessments. This is not done out of thin air. It links to the Sustainable Development Goals, but also quite importantly, it links to the policies that are already in place in the regions that want to enhance, for example, agricultural diversification. So you basically start proposing ecosystem-based adaptation or ecosystem-based disaster risk reduction measures that are linked to policies that are already in place, but you provide specific information as to where perhaps these approaches can be implemented in specific regions where the risks were the highest. So now, on purpose, I mentioned the Sustainable Development Goals and the biodiversity frameworks also that were on the previous slide, because you can go perhaps one step further. When we are talking about ecosystem-based approaches or nature-based solution, which you can see here in the center of this figure that was developed by Dr. Ivan Waltz from the United Nations University in a newsletter, policy brief from the Partnership for Environment and Disaster Risk Reduction, you can see how these can link to multiple intergovernmental processes, such as the Paris Agreement on Climate Change, such as achieving land degradation neutrality from the UNCCD, such as disaster risk reduction, which is a primary focus of this presentation, from the Sendai Framework for Disaster Risk Reduction, and from biodiversity conservation and the CBD processes. All this is underlain by the Sustainable Development Goals that you can see in the back of the picture. So everything is very much interlinked. And what this figure clearly shows is that when we deploy nature-based solution, the potential for addressing multiple targets is there. And therefore, we need to capture this also much more prominently. In the Living Deltas Hub project, which I mentioned before, where about the discussion about tipping points, the project was interested as a big picture about the sustainability of social ecological systems in deltas. And one of the components I was working together with Dr. Émilie Crémin, again, who is the main author of the papers on which the next few slides are based, was we were looking at how we can reduce disaster risks, in particular using nature-based solution. But it was clear that because of the focus of the project and because of the intrinsic link between nature-based solutions and disaster risk reduction and the sustainable development goals, that perhaps we can adapt the frameworks such as the Global Disaster Risk Index to start incorporating these notions of the SDGs or Sustainable Development Goals into the assessments. And one of the things that I haven't mentioned, but when we do the risk assessments, one of the starting points is often what we call impact chains. And this is a very small component of a much larger impact chain that was developed for the three deltas in which we were working in the Living Deltas Hub project, which were the Mekong River and the Red River deltas in Vietnam and the Ganges-Brahmaputra-Meghna deltas in Bangladesh and India. And you can see here in this impact chain or cause-effect chain, if you want, what leads to a loss of ecosystem services. And then how does that, if you connect this box to the other dimensions of risk, how does that increase the vulnerabilities of your systems? And in the process of doing that, we identified relevant sustainable development goals and targets that we could also use to combine the idea that we can use indicators that provide us information both about the disaster risk reduction potential of a measure, but also the sustainability of the social ecological systems that we're working on. So working really trying to address two things at the same time. Now, I don't have the final results because we're doing the final computations as it comes now, but this is how it's going to be framed. And you can see here explicitly some indicators that we're using from the Sustainable Development Goal process that we're integrating into our risk assessment framework. And as I said before, this is really to link disaster risk reduction, climate change adaptation, and sustainable development concepts and not to work in silos anymore. And therefore also reducing the risks of maladaptation. Because if you only look at one particular piece of a puzzle, you may provide solutions that are detrimental for other processes. So you could, for example, try to reduce risk with one approach, but then realizing that in the long term, this renders a system unsustainable with respect to economic development or social development. So this is what we're trying to do with this approach. Now, I talked about the impact chains just now, and what I want to emphasize with the next couple of slides is the importance of developing all these processes together with stakeholders. We're talking about very complex systems. I think you probably saw this when we looked at the figure on the tipping points. So we're looking at very complex systems, and the knowledge of experts, scientists, local communities, traditional knowledge holders is very important and needs to be combined. And when we develop the impact chains, such as the one I've showed you before, we have a large amount of consultations with stakeholders to try to understand all these cause-effect relationships, to try to understand which ones are the most important, and to try to understand which one we need to focus on in our risk assessments. And also in how we can identify the indicators that then become relevant to characterize these risks. It's also important to move at the local level for two reasons. And the main one is also because nature-based solutions, when we want to deploy them, they have to be very site-specific. A nature-based solution that works in one place will not work necessarily in another place, even if the hazard is the same. So you have to have really these locally adapted solution. And having these consultations allows you, as I mentioned before, to really understand what is important for a specific locality, both in terms of the risk reduction and the deployment of the solution if it's a nature-based solution. And this is research that was done with one of my former PhD students, Dana Sarikie, back in 2015 in Africa. And there, through interviews with local communities, he tried to understand what indicators would be important for risk assessment. This work wasn't done for nature-based solution at all. It was just done for a pure, simple risk assessment to floods and droughts. And you can see here the initials. So BF is for Burkina Faso, BE is for Benin, and GH is for Ghana. The ranking that the local communities were giving to some indicators. So prevalence of poverty was ranked the first indicator out of 7 for that component in Burkina Faso, 1 out of 8 in Benin, but only 9 out of 10 in Ghana. So in Ghana, the prevalence of poverty was considered a less important indicator. Degraded land was considered a very important indicator in all countries, and the access to extension services, again, you had some diversification here. So if you were going to do a risk assessment in each of these countries, you would need to really pick the indicators that are the most significant and drop the ones that are not significant. So this is just to emphasize the importance of the locality of the assessment, both for the assessment itself and then trying to identify the solutions that you want to put in place. We can also now increasingly base these assessments on knowledge and also propose indicators from the approaches that I have mentioned before. So here you have the qualification criteria for ecosystem-based adaptation, where an action is considered an ecosystem-based adaptation if it reduces social environmental vulnerability, if it generates social benefits in the context of climate change adaptation, etc. And with that comes some more specific guidance. So if you take reduces social and environmental vulnerabilities, which is the first qualification criteria, you can see quality standards in the second column, but you can see also example indicators in the last column. And where pertinent, some of these indicators can then inform your risk assessment framework. You also have now, since 2020, the IUCN Nature-Based Solution Global Standards with specific criteria that are noted and a series of indicators that can be used. I'm not going to read all of these, but this is additional information that can be used in the context of risk assessments. Another example, and believe me now, there are many examples. I just show you 3 here, is the handbooks that were produced by the European Commission and to which the Operandum project contributed on finding indicators to quantify the impact of nature-based solutions. And it has a coverage of 12 types of societal challenges in the context of the presentation now. The most relevant ones are climate resilience and nature and climate hazards. And some of the generic indicators that are published under these 2 societal challenges are presented here. And again, this can serve as a source of information to both test the impacts that nature-based solutions can have, but also perhaps to integrate in risk assessment frameworks. So to conclude, I'd like to go across some of the advantages and disadvantages of indicator-based approaches, generally speaking, but also in terms of the focus on indicators, the inclusion of indicators for nature-based solutions. So if we look first at the latter component, when you start doing the exercises, you can speak very well at a theoretical level, but then the reality comes in, and sometimes it becomes very difficult to find suitable indicators for vulnerability and risk assessment, generally speaking, for index-based approaches, but also perhaps it becomes a bit more complicated when you want to focus on ecosystems. And one of the main issues is then the data availability for the indicators, and particularly the data availability both in space and time. So in space, can you get it at the spatial resolution that you're interested in? And in time, are these indicators collected very frequently or not? The primary data collection can become challenging, particularly when you're working in very small areas. And this is often the case when you're talking about nature-based solutions. So here you need to have access to very high resolution data, or you have to do field surveys, which are time-consuming and expensive. The implementation and functioning of a nature-based solution also, we have to recognize that it can take a long time. It can take a long time for a nature-based solution to mature. And therefore, you need to have indicators that are reactive to this time. And this means that, the cost in logistics can be challenging. And let me illustrate this with this last figure, where on the y-axis you have the risks the risk level that you're trying to reduce, and on the x-axis, sorry, you will have the time. And you can see that the risk, of course, starts at a high level that you want to reduce, and maybe you implement your nature-based solution, and you will only have a very progressive risk reduction as the nature-based solution itself matures. And it may take quite a lot of time before actually the full disaster risk reduction potential of that nature-based solution materializes, which is what you see at where the line stabilizes. So you have to factor this into your risk assessments. And this is where also the solutions that I mentioned before, the hybrid solutions, where you have a mix of nature-based solutions and engineering solutions can come in play, because the engineering solution generally can provide the risk reduction potential much faster than the nature-based solution. I'm talking really in general terms here because there is a lot of variability in there. Also of interest is when you're working with nature-based solution, and particularly when you're working with vegetation, you may have a temporal variation within 1 year as to the effectiveness of the nature-based solution. So you can think, for example, of in temperate climate, the difference in vegetation coverage between the winter and the summer. So you have to factor this in, and you have to have the indicators that allow you to capture this also. Broader limitation of index-based assessments. So, and it links to what I was saying before. Typically, these index-based assessments are static in time and space, and they really consider that everything is linear. Whereas, as we know, in terms of socio-ecological systems, many of the processes are non-linear. The data that we want to collect, particularly when we're making comparisons, like comparisons across deltas, will be from different sources and from different years. So you may be comparing data that is from 2010 from a census statistic in 1 year, but the census statistic for another country may be 2015. So you're comparing different times. You always have to be careful about the data quality, availability, and sometimes a lack of gridded data sets, particularly once you want to project all this in GIS. The scale of analysis also becomes very important, because if you do a country scale assessment, for example, you will not be able to capture the differences between simply urban and rural environments. And we know that this is completely different when you're talking about risks to specific hazards. The level of risks are very different in an urban environment as opposed to a rural environment. And I'll skip the other two components, but basically these are some of the common limitations that the index-based assessments have. But there are also a lot of advantages, and one of the advantages is that the methodologies can be deployed rapidly. You can have a very good visualizations of the results through GIS, and that can be quite informative for the policymakers. And you can also start, when you have a refined analysis, specific areas where interventions are possible. And as I said, these frameworks are evolving all the time. I've shown you a few examples. And I think that they will continue to evolve with time, and as we have more and more data that is being generated through, for example, remote sensing and all these kind of things. So there are many advantages, but we always have to be aware of the limitations also of these approaches. And that's the end of my presentation. I thank you for your attention, and I'll stop sharing now.